Hello, hello. Today we'll be looking at PPOE subscriber scaling demo. We are presenting Rtbrick software solution (RBFS) along with Broadcom chipset, UFI space switch with access leaf rule, and DT's multiple subscriber QoS profiles prominently targeted at residential subscribers. Performance at scale is the agenda of the demo, which is split up as subscriber scale topology, subscriber scale configuration, and it ends up with subscriber scale output finally. Topology for today's demo is a Q2C 72XA access leaf with BNG Blaster and Ixia as a tester tool. There are two parts to the demo. At max scale of 12.8K subscribers with multiple QoS profiles budgeting, say 75% subscribers with 4 Qs in a Q group and 25% subscribers with 8 Qs in a Q group, it comes to 9.6K subscribers with 4 Qs and 3.2 subscribers with 8 Qs in a Q group, respectively. It's exactly the same QoS profiles DT uses on residential subscribers. Second part is limitations of Rtbrick Lab enables us to showcase subscribers at minimum scale with QoS profile installed on subscribers for upstream multi-level policing, remarking, and downstream queue scheduling, shaping, and remarking. Ixia VM ports and its capacity and connectivity to the DOT enables us to see fine granularity in QoS treatment on all 4K subscribers. So the first part, subscriber scale optimization is currently an ongoing activity in our engineering. We are pushing the threshold of chipset to scale further beyond 12.8K subscribers with different QoS profiles budgeting. Now, at max scale of 12.8K subscribers with two QoS profiles, forwarding daemon takes around 20 minutes to completely program all the entries in BCM tables. So since it takes time, let's trigger 12.8K subscribers using BNG Blaster, our in-house testing tool. We will revisit later as it takes time around 20 minutes to program all the scaled entries in the table. Now as we triggered, we can see the subscriber coming up. Here, the different parameters that we need to look at is the setup rate. The call setup rate that at any point of time, like per second, how many subscribers can log in. So that defines the setup rate, which is CPS. And the setup time, which takes less than 30 seconds to bring up all 12.8K subscribers. The setup time, which is a parameter that defines it. So now we see 12.8K subscribers have completely come up. Now, the traffic flows resolving of all these subscribers will be happening, which takes time. So let's see the QoS profiles configuration for all the scale subscribers. So there are two different QoS profiles that are enabled for scale subscribers. So PTA 4Qs double play. This is the profile that is installed on 75% of the subscribers, say 9.6K subscribers. So this profile within it contains different QoS components like Polisher, which is enabled with Polisher Residential as the profile, and scheduler map configuration, which is mapping Q to different classes and at different connection points of the scheduler. The scheduler that we have used in the current two different QoS profiles is strict priority. And the class to Polisher map profile defines which class is mapped to which Polisher level. Similarly, we'll see the next QoS profile. So this is the QoS profile with 25% of the subscribers are coming up with PTA double play 8 Qs. So this is also having a common Polisher, which is Polisher Residential enabled, and the difference is it is using PTA 8 Qs, where 8 Qs are mapped to different classes. So let's see the class to queue mapping. So here, 4 different classes are mapped to 4 different queues like BE, best effort, low loss, low delay, and VIVO. All the 3 different queues are mapped to 4 different classes. So the next one is 8 queues profile. Here in 8 queues profile, 8 different queues are mapped to 8 different classes. So here is where we are seeing the difference for 25% and 25% budgeting of QoS profiles. Now let's see the common polisher profile which is installed on all 12.8K subscribers. Here, multi-level policing is what we support. So in multi-level policing, the configuration says only the level 1 and level 2 have been used. And going further, the max AR and max PAR is what we also support. Say, the cascading of polisher levels is what we support in the chipset. So to limit any level to maximum, suppose 2 Mbps and 4 Mbps are 2 different levels. Say, let's take the same example. 2 Mbps and 8 Mbps are 4 different level polisher rates. Say, for level 1, there is no any traffic that is coming, and for level 2, there is a traffic that is coming. So, for level 2, the cascading means 2 Mbps and 8 Mbps, which comes to 10 Mbps. Suppose we want to limit the level 2 to 9 Mbps rather than 10 Mbps, that will be enabled through this max AR and max PAR configurations. This is about polisher profile. So let's see the scheduler map profile where any defined or selected scheduler, how the connection points will happen. Say if strict priority is the scheduler type that we have selected for this QoS profile, it is having 4 different priorities like SP0, SP1, SP2, SP3. So here, 8 different queues are mapped to 2 different priorities, like strict priority 0 and strict priority 1 are the mainly used priorities in this profile. And let's see the same for 4 queues profile. Here, all 4 queues are mapped to strict priority 0, which is the highest priority among different priorities. So this confirms what are the 2 different QoS profiles we are using as part of 75% and 25% budgeting to 12.8K subscribers. So let's revisit in some time, and now we'll go to the second part of the demo, which is mainly for QoS functionality. This we are doing on a different DOT where we are using Ixia as the tester tool. So here 10 gig ports are connected to the DOT. Here we are mainly focusing on 4,000 subscribers where we are showcasing for all the 4,000 subscribers upstream policing is happening or the downstream shaping is happening. To show the granularity and fixing it to a particular stream, we are choosing a single stream with class map to a polisher level. And let's see the on a different DOT. And let's see the QoS profile, which is a common profile that we are using across all subscribers. As we can see here, the profile that we are installing on all 4K subscribers is PTA double play, which is having polisher enabled with polisher residential as the profile and scheduler map enabled with PTA 4 queues double play as the profile and class queue map PTA 4 queues. And let's see further. Before policing any traffic, we need to classify the traffic. So let me explain further. Polisher that is used with respect to the classification here is multi-field classifier. Here, multi-field classifier PTA double play is enabled on a subscriber. So here, there are multiple qualifiers that can be used as part of the multi-field classifier. So here, we are using prefix as the qualifier for qualifying the traffic or classifying the traffic. So our targeted prefix that is coming with the traffic is this one. So if this is the case, let's see what will be the class that it has to classify and what is the remark that it has to do. So as we can see here any traffic that is hitting this has the prefix list that will get classified with class 3 and the traffic will be remarked with 184. It's actually a IPv4 toss since IPv4 as the qualifier we are using. And let's see the polisher that we are using here. So the polisher residential is the polisher profile that is enabled in a QoS profile for all the 4K subscribers. So here also it supports multi-level policing where we have chosen only level 1 and level 2 showcase the QoS functionality. So level 1 will polish at 100 kbps and level 2 will polish at 100 kbps. So let's see the class the traffic has get classified is mapped to which polisher level. So that we will get to know through class to polisher map. Now, different classes are mapped to different levels. So our traffic that it is hitting will be class 3. So which is mapped to level 1. So we will be expecting that the traffic will be incrementing at level 1. So now let's start the traffic. Before that, let's bring up the subscriber. And before that, let's bring up the IP connectivity or the internet connectivity. So this is our DOT, which is having the IP connectivity. And now we are making the subscriber to log in. So all these subscribers are logging in with a common QoS profile with different QoS components like polisher, scheduler map, and class to queue map. Now let's see how many subscribers have come up. Almost 4K are about to come. And now all 4,000 subscribers have come up. Now let's enable the traffic for all 4,000 subscribers, which is a bidirectional flow, upstream and downstream. And prior to that, the statistics that we are tracking is with source and destination value pair. So with that, 4,000 plus 4,000 for upstream plus downstream respectively, we will be expecting 8,000 flows that has to be enabled. And now we see further the frame rate that I am sending totally across all the subscribers is 100k packets per second, which is both the direction. And now let's start the traffic. And now let's see what is the transmit rate that is coming and the expected receive rate we know, the polished rate, which is the level 1 rate that we are expecting. So now if you can see the statistics here, the transmit rate is 200 kbps and the expected receive rate or the polisher rate is 100 kbps. It is having a fine granularity where 20 mbps is the offset we are seeing. So chipset is providing the fine granularity of 100 kbps, which is very well as per the installed rate of polisher rates. So here we can see 8,000 flows has been created, which is 4,000 for upstream and 4,000 for downstream. Now let's see the different tables here. We'll start from subscriber daemon. As we can see here, 4,000 subscribers has been installed. And let's see, and let me explain you the different subscribers which are with established count. So all the 4K subscribers are established, which the FSM states tells that. Let's see, even the last subscriber entry has been created. The loss sequence object tells what is the last subscriber that has logged in. So here it defines different parameters for a subscriber that has been configured. This is the user who is the last user, and he has been assigned with framed IP4 address, and what is the mask he is having, and what is the framed v6 prefix that is assigned with. And also accounting has been granted for the subscriber. And since the traffic has been started, before that, let's see the subscriber detail for this particular subscriber. So for which we need a subscriber ID, and the subscriber detail tells multiple parameters about a profile, which is the VLAN on which the subscriber have come up, and what are all the IPv4 profiles that has been enabled on the subscriber, like what is the IPv4 address that is assigned, and what are all the IPv4 DNS entries. And this tells what is the IPv6 prefix that is assigned to a subscriber, and also the DNS entries. And accounting has been enabled on this subscriber with accounting session ID. And currently we have configured the interim interval as 24 hours. So for every 24 hours, the accounting updates for the subscriber will go on. Now let's see the entries that are programmed at the hardware level. The main entries that we need to look at is the polyser entries, which is 4K entries for 4K subscribers, and the queue entries. The queue entries where we are expecting 4 different queues for a particular subscriber. So here we are expecting 16K entries, like 4 queues per subscriber, which is 4K into 4, 16K, the expected entries. And we do support statistics or accounting through which the upstream is tracked with polyser level stats, and downstream is tracked with class Q stats. So this is the table that tracks that 16K entries have been created for the polyser level stats, which is because 4 different levels, like multi-level is what we support per subscriber. So which comes to 4,000 subscribers into 4, 16K entries. And same is the case with Q entries. So this is the last subscribers Q entry. So let's see the counter that has incremented for a particular subscriber at this point of time. Since few minutes back only we have started the traffic for the subscriber, we'll be expecting some increment in the particular matching class and also matching level. So we are seeing here class 3 is mapped to VOQ. Here we are seeing the class 3 stats as incremented. Let's see the same for polyser stats. As we have enabled bidirectional traffic, we will be expecting both upstream and downstream traffic. So I am taking the same subscriber ID. Now, since level 1 is the polyser level where the class 3 was mapped, we are seeing level 1 rate has increased. So this confirms both for upstream traffic and downstream traffic, the statistic tracking or the accounting is working fine. From subscriber demand perspective, let's also see the accounting, where together it shows both the class and also the level stats or the counters. Here, the egress, which is the downstream traffic, where the class 3 is incrementing, and also for upstream, which is ingress polyser stats, where the level 1 is incrementing. This confirms even the accounting was working fine for the subscriber. So with this, the second part of the demo where at minimum scale, the complete QoS functionality is showcased. Now let's come back to the first part of the demo, that is 12.8K subscribers at scale, and look at various table scale entries that are getting programmed. Before that, let's see in BNG Blaster whether all the traffics are resolved. As we can see here, the traffic flows for all 12.8K subscribers as resolved. For 25.6K means both upstream and downstream traffics have resolved.